Okay. Welcome everyone to another episode of Edge AI Solutions. I'm kind of digging that music. Good morning, Jennifer.
Good morning, Pete. How are you?
Good. So yeah, we're here to talk about some more solutions. First, let me kind of address Jennifer. You look like you're in a very interesting place.
I am. I'm at Microchip Masters in Phoenix. Wonderful customer-facing event. I think this is about 3 decades of Masters events, and if you haven't had a chance to join one, definitely you should take a look at it for the future. They do have these shows globally. I know they're doing several in Asia here in the fall. As well as in Europe. So take advantage of it. This is 4 days of intense customer training, hands-on workshops. Avnet, of course, is here showing our Edge AI, projects that we develop on microchip technology. So you'll see our booth there in the background, but it's a lively event. Just getting started. It's about 8 a.m. here. And
Awesome.
You'll start seeing folks pass by. So I'll have to go off camera here in a little bit when it gets a little bit busy.
Cool. No, that sounds interesting. Yeah, I'm here in Bellevue, Washington. So no one's behind me as far as I can tell. But I might have a random cat come in here. But cool. No, good to hear that. And I suspect it's kind of maybe a little toasty out there, but you're inside in a nice air-conditioned environment. So
yes.
Yeah, good.
Always toasty in Phoenix.
Yes, always toasty. Hey, so folks, welcome. This is a live stream show, unless you're watching it as a repeat on YouTube or something like that. But it's a live stream show, and so you can make comments here and ask questions of our presenters today. We have some really awesome presenters. So just to let you know, whether you're on YouTube or Twitch or Facebook, we're actually on Substack now. So if you're on our Substack channel, our new Substack channel, you can see us there. We're also already YouTube's, StreamYard, yeah, pretty much everywhere. And I see we have George here from Kuala Lumpur, and it's 11 p.m. So George, thanks for staying up late on this one. And then we have Michael from the Bay Area, a little more my time zone, in fact, exactly my time zone. But yeah, so feel free to ask questions as we go. We will kind of break in and address the questions, as they come in kind of chunks. But feel free to kind of stack them up here as you go. So yeah, actually today we have some really special guests, and we have some folks from Dell as well as some of their colleagues. And yeah, so the title of this episode is Future of Precision Surgery. And just to clarify, we're not going to be doing any surgery on the live stream, so it's not that much of a live stream, but we will be talking about how Edge AI is being applied in the medical space and in the surgery space, and it's really fascinating and obviously very mission critical stuff. So Jennifer, anything else? I think we're going to have a little intro video, but do you have any other commentary on today's?
Well, I want to again thank our partner Dell, and brought all of these, brought this wonderful, healthcare use case of AI, right? Very practical, something that affects all of us, regardless of what industry you work in. So we're thrilled to have Connie, Krish, and Dr. Pfeiffer here to present on how they're using AI and something that can affect all of us. Yeah. And again, thank you to Daniel and CK at Dell for bringing this opportunity to us.
Awesome. Hey, so why don't we roll this intro video to kind of explain a little more about what we're going to talk about. Nice. I like that. Great. And I see we have a couple of more folks that have joined. We have Sanyade from London. We have Maxime from Berlin. Okay, so this is a good worldwide audience. And again, Edge AI Solutions is all about we like to build the tech, we like to optimize the tech, we like to build chips and software and make things, but applying Edge AI in the real world is really where the rubber meets the road. And that's what this show is all about. So why don't we bring on our first guest? All right. And Connie Iyer, welcome.
Thank you for having me today.
Yeah.
So before we really want to dive into a surgical AI story, I really want to paint the picture in a broader
Please.
context. Dell Technologies Healthcare with a comprehensive strategy that really spans our modern workplace, data center, and multi-cloud infrastructure, security and resilience, modern applications, and critically, artificial intelligence. We're not approaching AI as if it's an isolated solution. It's really integrated into every layer of what Dell delivers, from our AI factory and our optimized research platforms all the way to value-based care operations. Most importantly, none of this works without security. And we know that healthcare is a huge security risk, and cyber criminals are always after that healthcare data. So we keep that as a top priority. What this means is that zero trust architectures, cyber recovery, and secure electronic health records, as well as medical imaging, are really foundational, not just for our healthcare providers, researchers, payers within the industry, but for our consumers to really manage that data, care for those patients, action against that data, and most importantly, secure that data. So when we talk about innovation, we're talking about solutions that are built to be deployed and successfully scale, not just demonstrated, not just piloted. We want to help you really scale those AI solutions. So Dell Technologies' consideration around the full stack needs to support the current trends that we're seeing in healthcare is really what makes the surgical AI work that we're about to discuss possible.
Awesome. And by the way, Connie, I think one of the things that people maybe are starting to realize is that AI, it's not just about the models and how many billions or trillions of parameters, but it's really about all the stuff around the AI to actually make it deployable and useful in the real world, which is what we're all about, AI in the real world. So it's great that you're talking about, the security issues and the other things that, need to work to make AI actually a good return on investment, right? So that's pretty key.
Absolutely. But I really wanted to dive a little bit deeper into the clinical environment. As a registered nurse for the last 25 years, I can personally validate that healthcare is not a standardized workflow. What you're seeing right here is just one really clip of the different areas in healthcare. This is certainly not an exhaustive list. There are dozens of different workflow variances. Each of them have their own persona. Each has a different device needs and different demands in their workflow and their day-to-day care delivery. Really, from the moment a patient checks in at reception, whether they're using a self-service kiosk or some sort of tablet to sign in, all the way through the nurse's station, where care teams are leveraging those interactive display monitors, smart handheld communication devices. And then we look into the patient rooms. There is a whole growing area around telemedicine, remote patient monitoring, and then really getting into that surgical suite with medical grade devices. You have your AR and VR assisted procedures, robotics, really every single remote care, telemed room, every care workflow is different. Every single touch point has a very specific technology need, not just for the end users, those clinicians, but also for healthcare consumers. So beyond these very small examples, there's a growing trend in virtual command centers, shifting patients beyond the four walls of the hospital. That medical imaging, we're seeing a huge growth in AI-enabled interpretation to really help increase what we're finding on x-rays so things aren't going missed, as well as increase the speed to get those priority images read. And then a lot of home health management, biomedical research, patients that are on drug trials, to highly interactive sim and training and education that now remote staff can do, and it can get a lot better at that hands-on training that in the past we've only seen, in circumstances when we had people to test on.
Yeah. No, it's pretty amazing. I mean,
And then
go ahead.
look at the emergency responders, but all the stakeholders across getting those patients to the right organization as fast as possible to get those procedures. At Dell, we really take a persona approach on all of this so we can optimize that clinician user experience and really standardize the right technology for each unique role within the care setting. The reason this is really going to matter for today's conversation is that the operating room is one of the most demanding environments in this entire roadmap. And it's exactly where we have focused our research partnership. So I'd love you to see a little bit more, and thank you all for coming today. This is an exciting presentation.
Awesome. Yeah. No, I was going to say, for those that have been to a doctor's office recently, you take a look around and the amount of tech involved is incredible. And, empowering a lot of that tech with AI locally where the data is created is really making a huge difference. So it sounds like Dell's got a pretty big job on their hands making all this stuff work.
Right, Pete, but it's exciting times. It's really exciting times for us as consumers, right? With the right technology, the right security, the right access, and no delays, we're going to see major improvements in patient outcomes.
Awesome. All right. What's next? Let's see. I think we're going to bring on Krish from Dell, another Dell person. Fantastic. Krish, welcome.
Thank you, Pete. Thank you, Connie. That was an amazing intro to the work that we do here at Dell. I'm in the office of the CTO, and specifically in applied research. So part of our charter is to go look at new horizons for research. And one of the areas that we're starting to focus on is this whole notion of how can you bring AI-assisted surgery at the edge, and particularly in the, as Connie mentioned, the most challenging environment, which is the operating room. So one of the areas that we are partnered with is with National Center for Tumor Diseases in Germany, and specifically with their translational surgical oncology team. And they've been amazing partners. This is a collaborative research partnership with this translational oncology team. And the work that we are doing helps us bring in some of our expertise at the edge, our research expertise, and also leverage some of their deep expertise in surgery and some of the use cases around it. And then try to come up with a concept. Again, some of the work that I'm going to talk about today is not really a productized solution or something that you can buy off the shelf, but it represents a future of what we think surgical AI is going to look like. So this is really a demonstration of how translational research at NCT transforms into surgical intelligence that, as Dell CTO office, that we can support. So let me just give you a bit of a high-level intro to NCT, and we also have Dr. Micha Pfeiffer, who will be talking a little bit more on what NCT does. But in general, when we started off with this research effort, NCT was a uniquely demanding environment. So they had integrated cancer care, high complexity surgery, a lot of data to work with, and not much of that was unstructured. And really, with their strong mandate for translational research, it was essentially the right kind of setting for us in the applied research to really go and work with them to see where current AI trends meet some of their translational surgery requirements. So really, this is focused on three key things. Again, we didn't want to boil the ocean, but we wanted to keep it fairly, for lack of a better word, surgical in our approach. That we wanted to focus on three critical things. One is, how do we look at how do we ingest multimodal streams? Because obviously there's a lot of streaming data that comes out of operating rooms. How do we integrate that? How do we maintain and help with strict latency constraints? And third, how do we support inference and learning, which is obviously going to be required in an AI-enabled environment across from the operating room all the way to the core. So all of these were some of the key things that were areas that we wanted to focus on. So really, this collaboration with NCT is to improve surgical teams in NCT to help improve patient experience across some of the surgical environments. And it gives us, from a Dell perspective, it gives us a surgical reality. Again, we're not a healthcare company. We don't have that level of expertise. And this actually gives us that surgical reality where edge AI must really prove itself in the most demanding environments, if you will. So like I said, there are four things that we're working on. I'm not going to drain the slide, but really those are the four things that we're going to be focusing on. But one of the key things that I want to talk about is, in general, what really prevents surgical AI from working at scale, right? And this is not specific to NCT, or it's not specific to any organization, but in general, some of the challenges that you are going to see across the board is that there might be some level of disparate approach in the way you handle surgical data. I mean, it comes from various data silos. It's being generated from a variety of complex environments. It could be endoscopes, it could be sensors, and so on. So there's no common way to harness all that fragmented data that comes off it. The next thing is that, in general, most of these AI models have traditionally been managed in development environments. Really lacks that structure, the organization that you need to bring it into production, right? So that really needs a serious consideration in how do you bring that into production environments. And most importantly, even if you bring all of these things to fruition, you're going to need the right infrastructure right at the edge to be able to handle it. So that's a key thing that needs to be considered, because all of this data needs to be these insights at the operating room with the right level of latency, with the right level of tail latency, and with the right level of confidence has to be generated and addressed in the operating room. So really, that was a key thing for us. So it became really apparent for us that surgical AI really cannot scale until data, the AI models, and infrastructure really come together as one system, right? So that was a key thing for us. So our research really with NCT consists of three pillars, and those are the ones that you see out here. Again, I'm not going to go deep into this. We'll see a little bit of a high-level overview of a call flow later on. But really, what we proposed was, let's take a current issue in hand, okay? And that is, what do you do in an operating room while a surgery is happening, right? So our focus in this engagement has been around the intra-operative process of the surgery, right? And obviously, there are multiple processes, there are multiple things that need to come into place. There's a pre-operative part, and then what happens after the operative. But in order for us to really get a view of what we need to do and get a research collaboration going, we focused on the intra-operative part of surgery. And so one of the key things was, let's bring in a stream native storage for us to gather all the data. So a tiered stream native storage platform that brings in all this disparate data, orders them properly, stores them, and makes it available for the AI models to work. So secondly, what we did was we helped NCT containerize some of these AI surgical models and provide them with the right amount of data that's required for them to infer some of the streams that are coming in, and give them in an ordered and a structured way some of the data that they are required for them to infer and provide some inference on top of that. And finally, we carried out a task of migrating some of our cluster deployed POCs for video streams into a structured environment with the Dell GB10 environment, which is the surgical operating room edge environment that we are going to be required, that will be deployed in the operating room in order for this to happen. So really, our research is not about just building another AI model, but providing an environment for that to happen. So let's take a look at our, if you can move to the next slide here. Okay, great.
Yeah, by the way, I think there is a request to pause for some questions here. We had a couple of things stacked up. One was around, do you see a role for, I'll put it on here from Michael. So how do we think about like multimodal AI models working together? I mean, the idea of, there's obviously lots of different models other than transformer-based models that are in play here in the operating room and in the medical environment, but multimodal kind of combining like visual language models and other models together where you're almost getting like real-time assistance in terms of the data that's coming in. Is that on the horizon, or has that already been, prototyped, or where does that sit?
Like I said, right now our focus has been fairly, myopic in our approach towards intraoperative. But you're totally right. Some of the preoperative part and some of the things that need to be made available for a healthcare clinician or a surgeon or something like that is going to be invaluable. Imagine an agentic environment that pre-populates all the patient information, all the imaging stuff, all the clinical data,
all the context
that you're going to be needing, all that context be available even before the surgeon goes into the operating room, right?
Yeah.
So all that pre-operative stuff is going to be critical. But yes, again, we only have so many cycles, so our focus has been on a very specific part. But yes, though there's scope to increase our focus area to some of these really neat areas as well.
Makes sense. There's another one that came in here from Sanyade. I think just sort of comparing this to basically there's a lot of big data analysis going on here. So similar to like satellite data where they're pulling in tons of visual data, to find context. Inference will always be challenging. So I don't know if that's necessarily a question or just a statement that, you're dealing with a ton of data here. I don't know if you've quantified, I know we know in like, every time a jumbo jet lands, it's like a terabyte of data that they have to offload. I mean, what kind of data is being generated during a typical sort of operation? Do we have anything like that?
Yeah, that's a great question. I'm actually going to pause on that question because there's a lot of stuff coming up when Micha talks about it. This is essentially how NCT is going to handle some of the petabytes of data that they have. So I'll let Micha. I don't want to steal Micha's thunder.
Okay, don't steal the thunder. One more question, actually, from me, and so I've met some startups doing sort of surgical navigation stuff, which is really using edge AI for, if people don't know what surgical navigation is, imagine where the doctor's trying to figure out sort of where to make the incision exactly. And so obviously, if you can use kind of sensor data and some kind of AI to find the signal and the noise, you'll make a more accurate cut and a smaller cut, and it's all better. So that's called surgical navigation. I mean, is that stuff here that you're looking to deploy as well, the surgical navigation space?
It's again, the possibilities are fairly endless, if you will. Right now, what we're doing is a very limited set of inference activities. So, for example, we're looking at the liver segmentation model and figuring out what are some of the anomalies that we see. We're also looking at a instrument detection model to make sure that the instrument is headed the right direction, or the instrument is looking at the right anatomic part. So all of those these are the key models that we are looking at. But again, the infrastructure allows you for additional models to coexist. And so if there's a model that does that level of inferencing, then yes, the operating room, and I'll get into it in a minute after the slide, is the operating room infrastructure is going to have sufficient headroom for you to run additional models. And then that's one of the advantages of using a GB10 in that environment, because it gives you that additional headroom to run additional models.
Got it. Got it. Okay, cool. All right, let's keep going.
So let me jump into the thanks for the build out. So let me jump into this is actually a bit of a build out slide, but again, like I said, our focus has been on the intraoperative part of the surgery, and obviously there's a lot that goes on both pre-op and post-op, but right now, considering our scope, we're going to speak on the intraoperative part. So one of the whole idea behind this proof of concept and the research collaboration is, how do you harness the data that comes out of, let's say, an endoscope that is actually focused on in this case a liver. And so if you have to bring that video feed, where does it get stored? And that is the storage. In this case, is a stream native storage. It gets stored in the stream native storage in the right order, and to maintain what we call a temporal consistency of the video stream, it gets stored in a stream native storage. And keep in mind that this is what we call the hot path. In other words, the inference does not really wait for storage, because in this case, inference has to be instantaneous, because the video feed now is stored in the stream native storage, and the AI model that needs to infer that video stream is automatically activated. And there's an overlay that's made on top of that video stream, basically indicating where some of the anomalies are, what's the confidence level of the inference. And then basically, this is done on a pixel level. Keep in mind that this is done really at the deep pixel level, identifying some of the areas that the model has been trained to identify, overlays that with the level of inference that is made, and that is sent to the surgeon in real time. So as the endoscope is being inserted and as the video feed is seen, the surgeon is also being sent the overlaid inference in the monitor or in the VR headset or what have you, right? So all that is happening in real time with really low latency, right? So one of the killers in this case is what is called tail latency, and tail latency is kept under wraps. So that way the ordering and everything that gets sent to the surgeon's display is maintained with the right level of temporal consistency, right? So that's the key thing that we're doing right now is keeping this 100% local in the operating room. There's no cloud, there's no any other connectivity outside of the operating room. It's maintained inside the operating room. The GB10 in the operating room processes the data, stores the data, processes the data. AI models are running on it, overlays the appropriate inference on top of it, and sends it to the surgeon, right? So that's the intraoperative part that we're working on. And obviously, as you expand it, that data is going to be invaluable, right? So for example, that data needs to be tagged, that needs to be annotated. And so a clinician or even the surgeon after the surgery can go back and say, hey, I need to understand, or I need to see visually what happened in the surgery. So can you rewind the video a little bit so I can see it? What are sort of the annotations that were made on the video, and so on. So all of that is made available because that data that was stored in the stream native storage follows what is called a warm path, where that data after the inference is written into long-term storage and is made available for the clinician when they need it. And then on top of that, all the data needs to be trained, obviously, because that's what needs to come back into the model again, into the operating room. So all the data, the weights are being shared within the hospital consortia, and that is made available back to the surgeon. So this is in general a life cycle. Again, I talked about just one stream, but then keep in mind at scale, you're looking at multiple streams. So all of this has to be managed appropriately in the operating room. So again, like I said, this is a blueprint that allows the surgical surgery to happen at scale. So I'm just going to quickly move to the next slide here and just do a quick wrap up on what we just seen. So really, this demo emulates an operating room, right? So this is basically a model where a compute environment is running in the operating room. There are multiple models that run concurrently in this operating room. And then the whole idea is that our work with NCT is to prove that surgical AI can run locally under real edge constraints such as latency and jitter and all that stuff, and can run multiple models on a single edge device, and it needs to run predictably. So that's sort of the working assumption and the guardrails that we are working towards. So at this point, I'm going to stop, and I'd like to invite Dr. Micha Pfeiffer to talk about NCT and their innovation in the space. So over to you, Micha.
Welcome, Dr. Pfeiffer.
Thank you very much. Yeah. So as mentioned, I work at the NCT in Dresden. So good afternoon from my side. And we're a research facility, but we're situated directly on the campus of our university hospital. So we have a strong mission to try and bridge the gap between research and the clinic. And we work on various systems for intraoperative surgical assistance. And my personal interest is concrete systems that can really help directly during the surgery. So the hot path that Krish mentioned. And here on the left, you can see an example that we built in the recent past. So what we do here is we take the endoscopic video image from the endoscope in the operating room. We pass it to a custom-built consumer-grade PC. And then on that PC, we process it on the GPU, the image stream, and then send the results back out to a screen and add an overlay to the screen. So we compute an overlay using an AI model, and then the surgeon sees that overlay on the live video stream, basically. And this kind of system is really, really hard to test on real patients and in the real operating system, operating room, sorry. And so we're very proud that we now have a first proof of concept study running in the operating room with this. This is only on 12 patients for now, but with a very simple system, we can already see that we can help the surgeon. We got the feedback that it can help the surgeons in detecting smaller structures. So what the model does is it computes segmentation overlay of the live video stream, and then detects various structures that have been annotated in a large data set beforehand. And what the model doesn't do is it doesn't add additional information that is not visible in the stream. So it can help in some situations to detect small structures, but of course we want to take this a step further. And so what we do is we additionally to this video stream also use the information from preoperative data. For example, a CT or MRI scan that is usually done of every patient. And then from that data, we can build 3D models. And then we build fusion or registration systems. And then the idea is that we can navigate the surgeon towards a tumor or away from vessel trees that shouldn't be harmed. And this kind of fusion or registration system, if it works, in the end, we call this a navigation system. And for this to work, there's a lot of things that are actually being done or usually being done with AI systems nowadays. So we have segmentation, we need depth estimation, 3D reconstruction of the intraoperative scene. Usually we need some sort of pose estimation for the endoscopic camera. We might have a SLAM system running, we need key point tracking. And then of course, because a lot of times we look at soft tissue organs, we need soft tissue deformation. So we need to estimate how the preoperative data has deformed or changed live during the operation. And these all together are, of course, individually very complicated, but all together running them at the same time in real time in the operating room is very difficult. And this is where this cooperation with Dell really comes in, and where we hope that these in the future these can be run on Dell hardware. Yeah, and I mentioned 2 concrete examples here of what we're working on, but of course we want to take this a lot further. Our group already works on various fields, for example, surgical robotics. but also machine-human interaction. So how can the surgeon correct or modify what the AI does during the operation if the surgeon notices that there's something that the AI detects wrong, for example? Can the surgeon intervene and can we get the surgical expert knowledge into the AI model live during the operation? We're also interested in simulation at the edge. So, for example, as soon as a surgeon cuts into the liver model, we need to update the model live during the operation. And then it would also be interesting to detect adverse events before they happen. So if a serious bleeding is about to happen, if we could detect that and warn the surgeons just before it happens, we could maybe prevent larger issues during the operation. And all of these are future directions that we could tackle with Dell hardware, hopefully.
Wow. That's awesome. Good. So do we have any folks have any questions? There's a lot of information coming through here from the audience. I can pause for a second here, but yeah. Excellent. Oh, next slide.
Yeah, so let me thank you, Micha. That was really insightful. As you can see, there's a lot of cool stuff that's happening between Dell and NCT in the space. But I do want to leave you off with one specific takeaway from this collaboration. It's that technology only matters, especially in surgical AI. Technology only matters when it translates into better patient care, safer procedures, and so on, right? So that's going to be sort of our hallmark of the research that we're doing. And what we're trying to do at every step of the way is figure out how technology can help improve outcomes for the patients, for the doctors as well, for the clinicians. And that essentially is our focus. So value coming out of this is something that we're really focused on. And so this effort with NCT has been really fruitful thus far, albeit what we're doing right now is of narrow focus, but the whole idea is to increase it into a wider focus, to bring in some of the concepts that Micha talked about, bring in some of the concepts and ideas that that we got as commons into our research as well. Again, I do want to remind everyone that this is not an actual product or a solution that is available from Dell. We are leveraging a Dell GB10 based device in the operating room, but the whole offer, the solution, is a concept at this point. Right. And we're working with NCT on this.
Right. Awesome. Well, I think we have kind of a video that kind of visualizes some of the stuff we've been talking about. But we can play that and then we can come back and answer some more questions. So I don't know if Keaton, you have the video.
Second matters in patient care. When critical imaging data is locked away in isolated systems, vital answers are delayed, and that delay can change everything. Artificial intelligence is transforming the future of healthcare, and medical imaging is at the forefront of this transformation. The Dell AI Factory with NVIDIA breaks down barriers between systems, bringing imaging data together in one seamless, unified solution. Providers gain faster access to the insights they need, enabling critical decisions with confidence and speed. AI doesn't just speed up the process, it sharpens it. NVIDIA accelerated computing processes imaging data with unmatched precision, while Dell PowerEdge servers provide the scalable, reliable infrastructure needed to handle the massive data demands of modern healthcare. Together, they detect critical details that might otherwise go unseen, empowering providers to diagnose earlier and with greater accuracy. For patients, this changes everything. It means less waiting, less uncertainty, and care that's tailored to their unique needs. It means better outcomes, faster recoveries, and hope. Dell PowerEdge servers with NVIDIA AI infrastructure are purpose-built to advance medical imaging. Designed to handle the demands of modern healthcare, this technology transforms workflows, accelerates diagnoses, and improves lives. Because in healthcare, every second saved is a life changed.
Awesome. Wow. Yeah, pretty impressive stuff, folks. Really thank everyone for kind of walking through that. And obviously a pretty complicated, solution space. I mean, we haven't even talked about privacy and some other things, but the security aspects, privacy aspects, latency, performance, and then of course on the other side, the outcomes and impact can be pretty transformative. So why don't we see if we have a couple of comments here coming in, or questions, I should say, maybe not comments. So there's another question from Sanyad. So what about adopting knowledge ideas and what has been possibly achieved from self-driving technologies in the medical sector? So I know who you're taking away, Mo. Re-SLAM. So do you mean simultaneous localization and mapping? Like, is there some carryover in terms of what we're learning about autonomous vehicles and self-driving capabilities in terms of surgical navigation? Is there a cross-pollination there?
I think I can answer that because I mentioned SLAM on my slide.
Okay.
So yes, we do take a lot of models and ideas that are sort of from the general computer vision domain and then adapt them to the surgical domain.
Mm-hmm.
In some cases, it works very well. So we've made some really, we had some good experiences with recent foundation models, for example, that are often built on lots of simulated data, but also real world data that works surprisingly well on the surgical domain. But in the case of SLAM, for example, I'm not aware of any method that really fully works yet. So this is a really interesting topic, and I think one of our bottlenecks. And it's also one of the reasons why we often focus on organs that are mostly in view at the same time. So you don't need to sort of track everything where everything moves. You don't need a full model, but you see what you want to see in one frame. So you only need depth reconstruction, and that makes the problem somewhat easier. With SLAM, we just have this problem that we only have one view. We have lots of reflection. Everything is sort of the surfaces are all somewhat wet, so everything reflects from everywhere. And then a lot of times the view or the camera moves very suddenly because it's a very small area. And then when you move 3 centimeters, the whole view changes, and then there's a ligament that comes in and you lose all tracking. So SLAM or deformable SLAM is something we tackle and other research groups tackle as well. But it's an open research question, I would say. Yeah.
Interesting. Good. Okay, another question here. Let's see, from Top Shamrock. How does your OR node handle massive data throughput of live 4K surgical video feeds? I think it'd be interesting to dig into this. Actually, it was interesting. I was reading the other day why we don't watch NFL games in 4K. And part of the issue is the amount of data that needs to be transmitted live, through these cameras from the field, through all of the equipment and broadcast to my house is tremendous. It's incredible. And so that's kind of the reason why we don't watch 4K football games in the US. But I imagine like the 4K live surgical feeds, I mean, how are you managing that data? What kind of data are we talking about, like throughputs and stuff?
Yeah, I'm happy to take that. Thanks, Pete, for that question. It's a challenge. The challenge is not just the video feeds coming out. How do you store those feeds? And then how do you store them in the right order and make them available to a AI agent that needs it, right? So one of the areas that we're investing heavily on is this whole notion of stream native storage, right? As the stream comes in, how do you store those streams and temporarily and make them available to a agent that needs it and provides it in the right order, in the right temporal consistency, and to be able for that AI agent to handle it and make the inference. So it is a challenge. And one of the ways that we are doing today at least, is by using stream native storage.
Excellent. Yeah. So you're basically sort of kind of recording it slightly and then having the agent process the recorded stream.
Exactly. It's sort of like a DVR.
It's kind of a DVR style. It's like tape delay, as they call it. Interesting. Good. Here's another question came in from Michael. So if we wanted to accelerate edge AI adoption in surgical and medical applications, like where do we need to collaborate the most? Is it around standards? Is it around interop? Is it around sort of blueprint architectures? Is it around like better data sets? Like what are if you had to pick like the top 3 friction points to sort of more quickly deploy this stuff, what do you see up there? And Connie or
I would actually love to touch on that. This brings up a great latest. So this is the trend we're seeing, right? We are creating a Dell AI factory blueprint to make it much easier for our customers and partners to test and validate solutions, have a roadmap for that, right? So that will be coming out shortly. In terms of what do we need to really accelerate it? As far as Dell is concerned, our technology is capable of the acceleration that we're seeing, and that's the direction we keep moving. But to really see mass scale adoption, I think it's going to come from, above, right? We're already seeing federal regulations tied to reimbursement for 3 new CPT codes around AI, so organizations can get reimbursed. But it is a developing area. It's a gray area, right? Where is the liability? Data governance. So there are still IRB boards that are working on their own governance policies around AI. So we want to be cognizant of that. I think it's most important to remain flexible, and that is why you really want to work with your vendors and your partner ecosystem and whoever you're purchasing solutions from to make sure what you're purchasing is flexible, that you're not over procuring, and that you have the right amount of solutioning for today's environment as well as what's to come next, because we have all seen how rapidly this has grown in real time.
Cool. Good. Yeah, I had a question too, just for my own edification. So using this GB10, like how self-contained is the solution? Like you mentioned, no cloud. Is the idea, and I know this isn't a product yet, but the idea is that this GB10 can be sort of plopped down in an operating room with the right equipment that doesn't have, on-prem data center, or doesn't have cloud connection even. I'm thinking about, more challenging environments, right, than kind of a typical hospital in the US or Europe. Like how self-contained is this? And is that one of the value propositions, is bringing more advanced kind of capabilities to places that may not have it?
I'm happy to take that question, Pete. So in our testing, one of the key things that we were looking for is essentially what the ones that you just asked. Is, can this run standalone with absolutely no connectivity to the outside? Can it run, keep in mind that it's a medical device, can it run in a fanless and a quiet environment? Can it have the headroom to take on multiple AI models running simultaneously? Can it run a stream native storage on board for it to take on some of the video streams coming in? And oh, by the way, we also need to make sure that the thermals are under control.
Sure.
So we're not turning on a whole bunch of fans and so on and so forth, right? So those were key things that we wanted to test and run some metrics. And the good news is we were able to achieve most of those, in fact, all of those pretty well, at least in our testing. So we can say with fairly mature confidence that it's a great device to run as a standalone in an operating room, but also in a compute continuum environment. So keep in mind that at the end of the day, you're going to need this device to also serve within a continuum of products in the hospital network. So it would also be a product that serves within that continuum. But in our testing, it has performed really well in those constraints that you just talked about.
And so just to double click on the fanless part, why does it need to be fanless, or is that just a preference? Is that a medical issue, having a fan in the operating room? Oh, go ahead, Dr.
Maybe I can add on this. So one of the issues is that there is a very controlled environment, like from an airflow perspective in the operating room. So I'm not sure how it works technically precisely, but you're not allowed to bring lots of fans into the operating room to not disturb that kind of ecosystem. And in order to keep
too much.
And because you want to keep any contaminants away from the patient, and want to sort of create overpressure, I guess it is, around the patient, so that everything moves away from the patient. And then if you disturb that too much, that's that would be an issue, and that's why
that makes sense. That makes
norms
sense.
in place,
Yeah, you don't want to be moving a lot of air around, and I mean these days, you know, especially some of the high performance stuff you're talking about, and some using some NVIDIA chips, you know, it's typically fans are required. So I guess that will be solved over time. I mean, we're seeing lots of semiconductors from lots of different partners doing amazing AI acceleration with you know, orders of magnitude less power than they were just a generation ago. So ultimately that'll get solved. But yeah, really interesting. I had another question here around, and I'll throw this one in there, around kind of data boundaries and HIPAA compliance. So talk to us about, like, what are the considerations when using this kind of data, even though it may be somewhat abstracted and obfuscated, you know, for the purposes of kind of real-time surgery, around kind of HIPAA compliance? What kind of special considerations do you need when developing this type of system? Anyone can jump in on that one.
Maybe I can start with what we're currently doing.
Sure.
And then maybe Krish and Connie can comment on future directions. But so at the moment, we kind of take the easy route out and let our system know almost nothing about the patient. So the data that our system, our AI processes, is anonymous in the sense that it, without additional information, you couldn't reconstruct who that patient is usually. There are some caveats, of course. I mean, if you see a patient's liver, and you know a lot about the operation, and then you see that patient's liver again, then maybe you could find out who that patient
Identify,
is.
I see.
But that's like in practice, our data is anonymous. But it is a big issue and a big topic, of course, in all other methods. As soon as more patient data comes in, information about the disease or the progress of the patient through the hospital, then it becomes a large topic.
Yeah, and I would think also, like, using some of this data for training, you know, future AI models and things like that. Like, I don't know if that runs into sort of HIPAA issues, you know, or maybe there's some sort of, you know, sign off. The patient needs to say, yes, I'm willing to use my kind of operational data to train future data models or something. I don't know. But yeah, interesting.
For training, that I would say is the largest bottleneck. I mentioned before that we use models from general computer vision, but we can't train them on the kind of scale that self-driving cars could be trained, for example. It's nowhere close, right? When other foundation models are trained on millions of data points, we have hundreds if we're lucky. And so we need to do a lot of fine-tuning with anonymized data and that kind of thing.
Got it. Another question from Top Shamrock: does patient body structure build impact the model from a training perspective? Do you have to use similar patients? That's an interesting question. So obviously everyone's sort of shaped and sized differently. How much does that impact a solution like this? Do you have to train it on certain size people, or I don't know, how does that work?
Actually, the thing that I've noticed most,
we definitely see solutions.
Sorry, go ahead, Connie.
No, it's okay. Go ahead.
Okay, maybe I'll just quickly. So the thing that I've seen most is actually
just industry-wide. We do see.
Speaking of latency, I think we have some latency here between these cameras.
We do, yeah.
I'm glad we're not doing surgery right now. Connie, why don't you start, and then you do your thing. Now we can't hear Connie, I think.
All right. I'm going to start. So we are definitely seeing a rise in pediatric versus adult solutions. But I think that this is a very small window, right? We will immediately jump into AI models that are trained for everybody. Yes, we are all different shapes and sizes, especially externally, but internally, by and large, we are all humans. We are all created very similarly. There are some known anomalies, right? But those would be anomalies, and a lot of anomalies are even, very well known to the medical community, however rare they are. So I see this as a very small space. It will it will capture everyone. Not a one size fits all, but certainly adaptable
close
to all sizes.
Got it. Dr. Pfeiffer, I don't know if you have anything to add to that.
No, I agree. And it's something that we often test against as well. I mean, we always have holdout data sets, and often we have challenges, internationally run challenges, where we have patients that are not seen. So usually we always test on a unseen patient, not on a subset of the same patients. What we do see is that I come from liver or work on the liver. So what we do see, for example, if there are different stages of disease, then the liver can change drastically.
Sure.
So we've had situations where the liver is much grayer and darker and has a very different texture from what you would have otherwise. And then if you're not careful, you run into issues where the AI stops detecting that. And I think going forward, at the moment, the best solution is more data. And I hope that in the future, AI will also become slightly smarter and adapt faster to unseen patients.
Yeah. Well, probably last question. Will AI in medicine always be assistive and not autonomous? Always, is a long time, is forever. I mean, I think we can sort of envision right now somewhere where things become even more and more assistive over time. But I don't know if there's if anyone else wants to chime in on that. I don't think we have any autonomous surgery going on in the near future. Maybe even not even in the far future. So I guess that goes for all sorts of things that we're working on with AI. Hey, so just a interesting anecdote as we wrap up here. The advancements in medical care obviously have been fantastic, and what we're doing here with AI is amazing. I actually just finished watching this show on Netflix called Death by Lightning. I don't know if anyone's seen it, but it's about our 20th president, James Garfield, and how he was assassinated in around 1881. And interestingly, he did not die from the bullet. He actually died 80 days later from infection. And so back then they were not really using any kind of sterilization techniques. And so he ended up dying from all the infections from the surgery and trying to find the bullet and stuff, and not actually the bullet itself. So basically we've come a long way. And I guess if James Garfield was around today, he'd be in much better shape. But it's amazing to see the advances in what you guys are working on. I mean, obviously it's going to take a long time to sort of get this into market, but definitely the progress is amazing. And you're really solving some really, really difficult challenges in this space, technically, policy wise, security, all kinds of things. So really appreciate the efforts that are happening here. And this will be available on YouTube. People want to watch that. If they want to find out more information about this, is there a place at Dell they should go to sort of learn more, or call to action?
Yes, there are several publications that we made, so that is made available. But I'll let Connie also provide her thoughts on this.
Yeah, thank you, Pete. Thanks, Krish. And thank you, Michael, for joining us today. Testament to real world use cases and where we're seeing improvements in the OR. That's wonderful. Yes, as a takeaway, please don't hesitate to reach out to our team. We also have lots of customers globally, that you can see right here. Testament to the solutions. And this is an opportunity to collaborate and continue moving forward. This is not, like we've said many times in here, it's not a one size fits all. It's not prescriptive, but we have roadmaps, we have blueprints, and we have industry experts and full teams behind us, and our entire partner ecosystem and our alliances that can certainly help you achieve your goals, whether that's in the OR, in any other workflow, all the way to, research and hospital at home, don't hesitate to reach out to one of our specialists.
Awesome. All right. Thank you, everyone. And thanks, everyone, for tuning in. Hope you learned something, and take care. Thank you.